Technology, Warangal, and Department of Mechanical Engineering, I extend a warm welcome to all of you to the inaugural session of 5-day GIAN workshop on physics-based data-driven modeling in additive manufacturing and sustainable manufacturing technologies such as additive, coating, subtractive, and hybrid. We are privileged to have distinguished guests, faculty members, and participants with us today. May I now invite our esteemed dignitaries to kindly join us on the dais? Please, sir. Please join me in welcoming our beloved director, Professor Vidyadhar Subudhi. So, we wish to inform you that our esteemed director, Professor Vidyadhar Subudhi, is unable to join us in person due to some busy schedule. However, he will be joining us virtually to address and engage with us during the program. So, we'll welcome Director in Charge, Professor Ratish. Distinguished expert and project collaborator, Professor Chinapat Paniswas. Distinguished expert and project collaborator, Professor Shrikant Joshi. Distinguished expert and project collaborator, Professor Shrikant Joshi. Director in Charge, Professor Ratish sir. Dean of International Relations and Alumni Affairs, Professor S. Srinivas Rao. Head of Department of Mechanical Engineering and Workshop Coordinator, Professor Y. Ravi Kumar. Co-coordinators of today's workshop, Professor A. Venugopal. Co-coordinators of today's workshop, Professor. We will begin our program with a national song. I request everyone to kindly stand.
Vande Mataram, Vande Mataram, Sujalam Sukhalam, Malayaj Sheetalam, Sasya Shyamalam Mataram, Vande Mataram, Shubhra Jyotsna Pulakitaya Sumita Drumadala Shobhini Suhasini Sumadhura Bhashini Sukhadam Varadam Mataram Vande Mataram Vande Mataram.
Thank you. As we begin this significant occasion, let us illuminate our path with light of knowledge and wisdom. I humbly request all the dignitaries to kindly join us for the Jyoti Prajwalan.
Tamasoma Jyotirgamaya
Y. Ravi Kumar to give an overview of the Mechanical Engineering Department and the workshop on physics-based and data-driven modeling in additive manufacturing. Please, sir.
Respected Director in Charge, Professor Ratish Kumar, and two distinguished international experts. One is Professor Chenapat from Queen Mary University of London, and other one is Professor Srikant Joshi from University West, Sweden. Professor S. Srinivasarao, Dean, IRAA, and GN Local Coordinator, Professor Venugopal, my senior colleague, my dear participants, students, and my dear colleagues. A warm welcome to you all for the inaugural function. So I am delighted to stand before you that we are going to organize two GN courses. So the first one is on physics-based and data-driven modeling in additive manufacturing, and other one is sustainable manufacturing technologies, organized by the Department of Mechanical Engineering. And it's my privilege to introduce Mechanical Engineering Department. The Department of Mechanical Engineering exists right from the inception of the institute, that is 1959. The department presently offers one undergraduate program in BTech in Mechanical Engineering with an intake of 165 students. And the department offers 5 MTech programs in various specializations, namely thermal engineering, manufacturing engineering, computer integrated manufacturing engineering, machine design, and automobile engineering. The department is also offering doctoral degrees in various fields of mechanical engineering. Presently, the department has 90 full-time and 40 part-time scholars on rolls. At present, the department has 50 regular faculty with research experience in various specializations in mechanical, and the academic labs are equipped with good experimental facilities like 6-axis milling machine, IR camera, machine, 3D printing, friction and wear tester, air jet erosion, wheel alignment, vehicle onboard diagnostic, to name a few. Department has liaison with reputed industries and R&D organizations such as NFTDC, DMRL, DRDL, RCI, ASL, ARCI, BHEL, GTRE, ADA, and more. The department has acquired a funding about 5.5 crores through external funding projects from DST, SCRB, DRDO, and so on. And the department also has Center of Sustainable Energy Studies, Hexagon Capacity Center as a Center of Excellences, and also department associated with Center of Excellence for Digital Manufacturing and Automation. Pleasure to talk. One of the GI is physics-based and data-driven modeling in additive manufacturing. So we have 60 participants. So out of 60, 36 are students, that is PhD scholars 32, PG students 3, UG students 1, faculty 19, industry and scientists 5. And among 36 and around 18-19 participants are registered for the credits. And coming to the participating institutions, so we have 8 IITs. One is IIT Madras, IIT Kharagpur, IIT Roorkee, BHU Varanasi, IIT Jodhpur, IIT Ropar, IIT Jammu, and IIT Tirupati. And we have 3 participating NITs, NIT Trichy, NIT Nagaland, and NIT Warangal. And other institutions like VIT Vellore, PSG Coimbatore, Anna University, Amrita, and so on. And we have participation from NITTR Chandigarh, RR CAT Indore, GMRL Hyderabad. And coming to additive manufacturing and NIT Warangal, so we have a close association. So we at NIT Warangal took the initiation first time in India to start a PG program with a specialization MTech in additive manufacturing in collaboration with Central Manufacturing Technology Institute, CMTI Bangalore. We launched this program from academic year 2014-15. And if you see the global, so it was valued 15.10 billion US dollar in 2021 and is projected to grow 18.33 billion US dollars in 2022 to 83.90 billion US dollars by 2029. So which we can see the cumulative annual growth rate is 24.3% during this forecasted period. So rapid increasing digitalization, increasing adoption of advanced technologies like Industry 4, smart factories, robotics, machine learning, and other fuel the demand for the online additive manufacturing or 3D printing for simulation purpose. And this course is very well connected to the simulation. And if you see the applications like aerospace companies, so they are using this technology to manufacture various hardware parts. For instance, Boeing leveraging industrial 3D printing to manufacture the interior parts of the plane, and NASA using to build the rocket engines and parts of the satellites. Automobile industry expecting to show a huge adoption of this technology. Rapid tooling incorporate with additive manufacturing has become the priority of many automobile manufacturers. Customization of automotive interior is another major application of technology in automobile industry. So one of the biggest obstacles has been cost, but now the companies like MakerBot, Ultimaker printers, now you can buy at around 2000 USD, that is 1.2 lakhs Indian rupees. Roughly it is the equivalent amount of a basic Apple iMac computer. So coming to the deliberations during these 5 days, so we have planned 10 theory sessions, each of 1.5 hours, that is total 15 hours, and which is going to cover fundamentals of mechanistic modeling, modeling and simulation of laser powered by additive manufacturing for microstructure and mechanical properties, thermomechanical modeling of additive manufacturing for calculating residual stresses and distortion, fundamentals of data-driven modeling and its application in AM, multi-scale, multi-physics modeling of heterogeneous non-equilibrium microstructures in metal AM, design for additive manufacturing and basics of machine learning, and finally integration of physics-informed machine learning and data twins to additive manufacturing. So these are the theory sessions. And coming to the lab sessions, so we have around 7 labs, and which is catering to prediction of composition changes by machine learning techniques using open source software, design for additive manufacturing, generating lattice structures, simulation for defect reduction and microstructural prediction using ANSYS software, build setup preparation for metal additive manufacturing using 3D expert software, working on metal additive manufacturing machine, and post-processing techniques for metal additively manufactured parts. And coming to the examination, who opted for credits, maybe around 18, 19, I need to check, maybe 18, 19 or register for the credits that we are going to earn, and we are going to conduct a test. On the hands-on practices, the 50% weightage will be given to the evaluation process, and 50 marks quiz at the last day. And you are going to earn 2 credits. Why? Because it is 29 lectures has been going to deliberate here. So with this, thank you for the opportunity given.
Thank you so much, sir, for shedding light on departmental activities and vision, and also for the insightful overview of the workshop. Now I invite Professor A. Venugopal to give an overview of the workshop on sustainable manufacturing technologies. Please, sir.
Good morning, one and all. The distinguished guests, the international experts for both the GAN programs, Dr. Channapat Viswas for the course on physics-based and data-driven modeling in additive manufacturing, and Professor Shrikant Joshi for the course on sustainable manufacturing technologies, including additive, coating, subtractive, and hybrid. Our beloved director, Professor Bijadar Subudhi, who will be joining online, and Professor Ratish Kumar, who is the in-charge director, acting director for today, and Dean International Relations and Alumni Affairs, Professor Srinivas Rao, Head of the Department, Mechanical Engineering, and also the coordinator of one of the GAN courses, Professor Vairav Kumar. My colleague, Dr. Manjiya, another coordinator along with me for the second GAN program. Participants from various engineering colleges, faculty, and students. It gives me a great pleasure to welcome you all for the GAN course on sustainable manufacturing technologies, additive, coating, subtractive, and hybrid. In fact, manufacturing has always been a keystone of progress, driving technological advancements and economic growth across the globe. The traditional methods of manufacturing often involve high energy consumption and significant material waste. However, as we navigate these challenges of the 21st century, climate change, resource depletion, and global population growth, it has become clear that the development of sustainable manufacturing methods is necessary. Of course, we all know that sustainable manufacturing aims to create products through processes that reduce environmental impact, conserve resources, and promote economic and social sustainability throughout a product's life cycle, from design to disposal. This 5-day course offers hands-on knowledge in two advanced areas of sustainable manufacturing, that is additive manufacturing and surface engineering. Of course, we all are aware that additive manufacturing builds components layer by layer from digital models, enabling complex, lightweight, and material efficient designs. AM reduces waste, shortens production time, allows easy customization, and minimize emissions by enhancing material and energy efficiency. Surface engineering modifies material surfaces to improve properties like hardness, wear and corrosion resistance, and thermal stability. Advanced coating techniques extend product life, increase efficiency, and reduce environmental impact, lowering resource consumption by minimizing replacements. This course covers principles and applications of AM and surface engineering with insights into integrating these with traditional manufacturing. Participants will explore case studies and real-world applications aligning with India's Make in India and Skill India initiatives. The interdisciplinary nature of this course reflects the complexity of sustainable manufacturing. It requires expertise in material science, engineering, design, and process optimization, coupled with a strong commitment to protect the environment. We are privileged to have the leading experts, both from academia and industry, Professor Shrikant Joshi from the University of West, Sweden, the international expert, and also we are going to have two more experts from industry, from India, Mrs. Dr. Deepa Srinivasan, who had a vast experience working in GE and Pratt & Whitney, and now she is also associated with one of the private engineering colleges in Bangalore, Ramaya Institute of Technology. And Dr. Santosh Nagaraj, who is working in Hexagon. They'll be sharing their knowledge and experiences with us during these 5 days of the course. Through interactive lectures, practical demonstrations, and collaborative discussions, this course will provide a robust platform for learning, innovation, and networking. Before we proceed further, I would like to express our heartfelt gratitude to the management of all the academic institutions for sponsoring their faculty and students to attend this GAN workshop. In fact, the participants' composition is like this. We have about 13 faculty members joining from various parts of this country. PhD and PG students about 20, and undergraduate students about 10. We hope the insights and skills gained during this workshop will enrich not only your individual journeys, but also contribute to the progress of your institutions and the broader academic community. Once again, thank you for your invaluable support and participation. Let us make this workshop a productive and impactful experience for everyone. Thank you.
Thank you, sir, for such a thorough and comprehensive overview. I would like to invite Professor M. Manjaya to introduce our distinguished international expert and project collaborator, Professor Chinnapat Paniswas from Queen Mary University of London.
Thank you. It's my pleasure to invite the guest on the foreign expert for this one of the GIAN program, Dr. Chinnapat Paniswas. He is currently an associate professor in the Materials and Solid Mechanics department, and as well as a deputy director of graduate studies, and as well as director for the Material Science and Engineering program at School of Engineering and at the Queen's Mary University of London. And he joined this Queen's Mary of London in 2022 July, and he obtained his PhD degree from Metallurgy and Materials Engineering from the University of Birmingham in 2013, and he got his the BSc degree in the first honors in the physics department from the Choklong University of Thailand in 2008. After conferment of his PhD, he joined a partnership of the Research Simulation Manufacturing Materials Research Group at Rolls-Royce and University of Technological Center at the University of Birmingham from 2013 to 2018. And in the year of 2018 June, he was awarded EPRS Ukeri and as well as Innovation Fellowship to conduct his research project, and as a principal investigator on additive manufacturing materials, and as well as a senior fellow in the EPSRC Innovation Fellowship at the Department of Materials from the University of Oxford in the London. And before joining to Queen's Mary University of London, he was an associate professor in the digital manufacturing, associate director of NASCO UK Research Center, and as well as innovation fellow at the School of Engineering, University of Leicester. And with this, he has vast experience in investment casting, and as well as laser and electron fusion bed welding, as well as additive manufacturing, and he has more thorough on the numerical modeling of additive manufacturing aspect. His main research interest focusing on the multi-scale materials modeling of liquid and solid interactions, particularly aim of high performance alloys using the integrated computational engineering materials ICME approach. And as well as Dr. Paniswas holds his visiting professorship at Chulalongkorn University at Thailand, and as well as Shimane University in Japan, and as well as Shanghai Jiaho Tonggo University at the China. And also he is a visiting academician at the University of Oxford and as well as University of California, USA. With this brief introduction, I will welcome to deliver the inaugural session. Thank you, sir.
Thank you, sir, for the kind introduction. Please join me welcoming Professor Chinnapat Paniswas to address the gathering. Please.
Thank you very much, Professor, for the kind introduction. And I mean, first of all, I would like to thank Director, Deans, and the Head of Mechanical Engineering for the invitation, and also all the very good hospitality that I received this day. So I'm very honored to be here to talk you something about my experience in the fundamental of modeling of additive manufacturing. And I believe this will be a good step forward for us for the further collaboration in research and also education in the years to come. So thank you very much for organizing this and your hospitality. Thank you.
Thank you so much, sir. I would like to invite Professor M. Manjaya to introduce our distinguished international expert and project collaborator, Professor Shrikant Joshi from University West, Sweden.
Once again, I am warm welcome to all of you, and it's my pleasure to introduce the guest and as well as the international expert, Professor Shrikant Joshi. He is one of the GIAN program foreign expert in sustainability additive manufacturing process, hybrid and subtractive, and as well as hybrid manufacturing process. And Professor Joshi is an accomplished chemical engineer with over 3 decades of experience in the academia and as well as industry. He currently serves as a professor in the Department of Engineering Science at University West, Sweden. And Dr. Joshi obtained his PhD in the chemical engineering from University of Idaho in 1987, and MS from the Research Polytechnic Institute in 1983, and BTech Gold Medalist from Usmania University in 1982. And Dr. Joshi professional journey spans several leaderships and research roles. Since 2015, he has been working as a professor at University of West, contributing significantly to the research in surface engineering and material sciences. And prior to this, he held a roles of International Advanced Research Center for Powder Metallurgy and as well as New Materials, that is at ARC in Hyderabad, as Associate Director, including the Additional Director from 2013 to 2015, and as well as Associate Director from 2005 to 2013. Additionally, he serves as a Dean at University of Hyderabad School of Engineering, Science and Technology from 2008 to 2009. And also prior to that, he was working as a scientist as DMRL almost 15 years before joining to ARCI. And he is an expert in the additive manufacturing, thermal spray coatings, and laser surface engineering, and also is working in the area of electron beam processes. And Dr. Joshi research interest mainly lie in the intersection of the advanced manufacturing material sciences. He had led numerous high impact research projects such as advanced coatings for the enhanced sustainability project funded by the KK Stephen in 2023, and Green Bat project on solid state lithium batteries funded by the Vinova in 2022. His work also extends the coating for the solid state thin film batteries under the Novel CABS projects in 2021, and high performance coatings for the industrial applications and Ipraco Coat project in 2019. And Dr. Joshi's experts has been recognized through the various prestigious awards. In 2023, he was inducted into a Hall of Fame by the ASM Thermal Spray Society, and he holds a fellowship with the notable organizations including the Institute of Materials, Minerals and Mining IOM3 UK, and also as well as ASM International. His accolades includes the Metallurgist of the Year Award from India Ministry of Steels in 2009, and Vaishak Research Award in Material Science and Technology in 2011. Dr. Joshi has contributed extensively to academic literature. Over the 200 peer-reviewed journals he has published, and 12 book chapters he has published, and 4 books he has edited in surface engineering and thermal spray coating technologies. And he holds 8 patents, and also he filed 6 more patents. He is undergoing the innovation in the contribution of the materials engineering aspects. He remains as actively involved professional societies including ASM International, Material Research Society of India, and the Institute of Indian Metals. With this brief introduction, I welcome you, sir.
Thank you, sir, for the kind introduction. Please join me welcoming Professor Shrikant Joshi to share his insights with the gathering.
Good morning, everyone. I'm going to be speaking for the next 5 days, so I won't take too much time this morning. But for me, it's a great pleasure to be here for several reasons. First is I'm coming on this beautiful campus after 15 years almost, and it's lovely to see the changes that have happened. On a more personal note, I'm very delighted also to be here because as additional director of ARCI, I wanted to put in place some mechanism for our senior research fellows to pursue higher degrees while they were working with us at ARCI. And as part of that, this institute was the first one with which we established a joint PhD program. And I recall seeing Professor Venugopal and signing an MOU with this institute in that capacity. So it's a great pleasure to see that that program still continues. If I remember, me and Professor Venugopal had the first joint PhD student as a part of that program. Of course, I left before the guy finished, but it's good to see that that program continues. Coming back to additive manufacturing and particularly surface engineering, it has been my first love. I must say second, otherwise my wife will be upset. Yeah, it's been my second love, and it's a little bit complicated, as I was telling both Dr. Manja and Professor Venugopal, to run a course like this because on both of these subjects, we run a course that runs the entire semester. right? So to pack this both into 5 days and then deal with bachelor students, postgraduates and faculty in the same course, uh, yeah, it's a little bit tough. But I want the engagement to continue beyond these 5 days, right? And I'm also hopeful that uh, being here today will perhaps get started a three-way collaboration involving your university as well. I'm really looking forward to that. So thank you very much. I will see more of you in the next 5 days, of course. Thank you.
Thank you so much, sir. We will now hear a few words from Professor S. Srinivas Rao, Dean of International Relations and Alumni Affairs.
Good morning to all. Respected Director of NIT Warangal, Professor Vidyadhar Subodhi, he is joining through online, and Professor Ratish Kumar, in charge Director, and respected foreign faculty, Dr. Chinnapat Paniswas and Professor Shrikant Joshi, and coordinators of these two 5-day faculty development GAN courses, Y. Ravi Kumar and A. Venugopal, and another co-coordinator Manjaya, and all the faculty members of Department of Mechanical Engineering, and the participants who came from different parts of the country for attending this 5-day GAN course. So good morning and welcome to all of you once again. So these 5-day GAN courses, or two courses are starting today. All of you know that one is physics based and data driven modeling and additive manufacturing, and sustainable manufacturing technologies, additive, coating, subtractive and hybrid. So one course is on additive manufacturing, other course is on additive and subtractive manufacturing technologies. So by attending these courses, all of you will be getting exposed to the latest technologies in additive manufacturing. So I thank these faculty members for initiating for writing a proposal for this GAN program and contacting the foreign faculty members, and they have shown a lot of interest, and finally Government of India has approved, and by crossing all these process and all this course was approved, and we are very happy to see foreign faculty members here, and their interaction will be definitely useful for all of us for developing the research advancements and technological developments in the area of additive manufacturing as well as additive and subtractive manufacturing technologies. So myself, I am S. Srinivas Rao, Professor in Department of Electrical Engineering. I am holding an additional charge of Dean International Relations and Alumni Affairs for the tenure of 2 years duration, started from this year July 1st. So this Dean Office, Dean International Relations and Alumni Affairs Office is coordinating different programs sponsored by Government of India, and also the collaboration made by various faculty members with foreign universities and institutions for technological advancements and increasing research potential at NIT Warangal for the benefit of faculty members as well as the students who are studying in these institutions. And at the same time, by this type of programs, we are calling the faculty members from different parts of the country, so that all will be getting exposed to the latest technologies by listening to the foreign professors. So along with this GAN course, this Dean International, this office will look after the another programs, that is Spark Scheme for Promotion of Academic and Research Collaboration, UK India Foundation and Research Initiative, Heritage Program, BRICS, DAD and MITAX, etc. These type of sponsored programs are also handled by this office, along with the alumni relations. And this GAN course, about GAN course, Government of India in 2015 has initiated this global initiative for academic networking in higher education, aimed at tapping the talent pool of scientists and entrepreneurs internationally to encourage their engagement with the Institute of Higher Education in India, to enhance the technical collaboration for the benefit of the society as a whole. These programs are not only confined to the one country or one region or one area. These research areas are identified, and these programs are conducted for the benefit of the whole world. So till now, this is the GAN Phase 4 program is running. Under this program, these two are the first courses started in this year, this Phase 4. And previously, we have successfully completed the GAN 3 phases. In 2015-16, 27 courses were conducted under GAN Phase 4 with a sanctioned budget of 1.87 crores. In 2017-18, 41 courses were approved and conducted for an allotted fund of 2.48 crores. In 2019-13, 21 courses were approved under Phase 3 with a financial assistance of 1.41 crores. In this 2014-15, we have got 20 courses for an amount of 1.45 crores. In this series of this Phase 4 program, these are the course first or second, which course we may call as the first or second. These two courses are starting in the Phase 4. So I thank all the participants for showing interest to come physically and attend this program, and I thank once again the foreign experts for coming physically to interact with our faculty members, research scholars and institutions. This interaction will definitely useful for us to develop a collaborative research. So I wish all the best for these two programs, and once again I thank the coordinators for conducting this inaugural program of these courses combinedly. Thank you one and all.
Thank you so much, sir, for the valuable insights and encouragement. I now request our in-charge director, Professor Ratish, sir, to address the gathering.
Okay, so good morning to you all, and welcome to this wonderful two GYAN programs. Dignitaries on the dais, Professor Chinnapat and Professor Shrikant Joshi. Professor Chinnapat from Queen Mary University of London, and Professor Shrikant Joshi from University West. I'll call it as University West at Sweden, rather. And then dignitaries, Professor Srinivas Rao, the Dean IRA, and the director, both the coordinators of two GYAN programs together. In fact, Professor Venugopal, Professor Ravi Kumar, and Professor Manjaya, so who are organizing two GYAN programs together. And then participants, faculty, participants, and students, etc., student friends. So welcome to you all to this 246-acre, I should say, green sprawling campus, spread into two phases, in fact, north and south campus in this institute. And this institute, for the information of everybody, is established in 1959. In fact, with one of the mechanical engineering is one of the branches which was there right from the inception of this institute in 1959, along with civil as well as electrical engineering. And we have grown strength to strength, of course, in the past 1.5 years with the leadership and stewardship of our beloved director, Professor Subudhi. In fact, there's a lot of changes which have taken place in terms of, as Professor Shrikant Joshi is mentioning, there's a lot of change in the campus, sir. We have seen the green luster, and then a lot of infrastructure have been added. And then there's a lot of, progress in terms of, research and development, in terms of publications, in terms of patents, in terms of technology transfer, in terms of overall, there is a very broad outlook changes have taken place in the last 1.5 years. In fact, under the able guidance and leadership of our beloved director, Professor Subudhi. Of course, coming to these two programs, I'm not an expert in this area, but I work in the area of civil engineering. I'm a civil engineering professor, basically. I'm also the Dean Planning and Development in this institute. I only say that, I mean, one of the topics is related to physics. Okay, I think physics-based data-driven modeling in additive manufacturing, right? So I think this is something like, something like for 3D printing, which we do normally in civil engineering, as part of civil engineering part is concerned. Additive manufacturing is something like 3D printing also, in fact. I mean, we do 3D printing of concrete and mortars. That means the cement, fine aggregate, etc. Maybe concrete, cement, fine aggregate, and coarse aggregate. And I think that's similar to this because you work in the area of metals, and maybe the same approaches related to the physical models and maybe data-driven approaches, including your machine learning, etc., might be is a part of this to probably improve the efficiency of this 3D printing process in manufacturing for better prediction of material behavior, etc. Maybe the precision is one more very important part. I think it also involves, as I understand, the real-time optimization part might be there for the manufacturing process, leading to better precision, faster production, and more reliable outcomes in the additive manufacturing applications. I think this should be the nutshell of what you are basically doing as far as the first course is concerned. Now, as far as the second course is concerned, it's more like, the sustainability related. And as Sir was telling that, this is a second love, additive manufacturing is second love. In fact, there's a beautiful love triangle between what we normally call it as strength, durability, and sustainability. So I think you are touching upon the third aspects, in fact, without compromising on the performance in terms of strength as well as durability. I mean, that's a common ground between all the different branches. I think the focus will be more on reducing the material waste and implementing energy efficiency. I think the words like adding means adding layer by layer as we do in 3D printing, and basically for minimizing the waste, while subtraction probably means your something like removing the material from a solid block or something like that, offering precision, right? And then coating, as I understand, is something like what we normally understand is in terms of improving the properties like corrosion or wear resistance, or improving the durability aspects, and probably I mean to say the surface properties. And hybrid techniques probably will include everything, like optimizing the sustainability, addition, coating, as well as subtraction, everything. So this is what I basically understand from this, and I really see that there are two great experts, one from Queen Mary University, London, as well as the other from University West at Sweden. I request both these experts also to spend some time going around the campus, and also, if possible, we can try to go for a sort of memorandum of understanding between these three universities, India, Sweden, as well as London, all the three universities. And I also request the participants to have a good time in the campus, and then don't just only concentrate. I mean, of course, it's a captive audience. When you say NIT Warangal, it's a captive audience. But at the same time, please try to explore, try to meet all the professors who are there in the department, because everybody is a gem in this in the Department of Mechanical Engineering, so they have their own expertise. I request that the participants who are coming from different parts of the country to please interact, and then probably you can try to make up your research collaborations, or maybe some students are there who can actually join in PhD courses, etc. And probably also when you go back, you see all the campus, the planning, etc. We have done a beautiful infrastructure has come and is coming. In fact, we are doing with something like a 450 crores of work we are doing with a lot of things which are coming up in terms of the lecture hall complex, residential quarters, and then we have a 2,500 seated amphitheater. So several things are basically coming up on the campus. So I wish you will have a pleasant time in this campus, and then when you go back, please take all the good things and then speak good about NIT Warangal when you go back. So thank you very much. Thank you.
Thank you so much, sir, for the valuable guidance and interaction. I request our beloved director, Professor Vidyadhar Subudhi, to address the gathering.
A very good morning to all
Thank you so much, sir, for your inspiring leadership and vision for NIT Warangal. We are humbled that in spite of your busy schedule and commitment, you have made it to the point to interact with the audience. We now move to releasing the course material. I request the dignitaries to kindly join us for making this occasion. Thank you, everyone. A heartfelt thank you to all the speakers, dignitaries, and participants for joining us today. I now invite Professor M. Manjaya to deliver the vote of thanks.
Good morning once again all. It's my privilege to deliver the vote of thanks for these two GIAN programs. First and foremost, I extend my heartfelt gratitude and esteemed international experts, Professor Shrikant Joshi and as well as Professor Chinnappat Paniswas, for gracing this occasion with their presence and sharing their valuable insights over the programs. Your contributions have set to an inspiring tone for the program and emphasizing the critical importance of sustainable practices in manufacturing technologies and as well as numerical modeling in the additive manufacturing aspects. A special note to appreciation goes to our Professor Vidyadhar Subodhi, our respected director, for their unwavering support and encouragement, which has been instrumental in making this event reality. And I also wish to express my sincere thanks to our the in-charge director, Professor Ratish, for his presence and gracing this occasion. And I also would like to thank our Dean International Relationship and Alumni Associations, Professor Srinivas Rao, for his continuous, consistent guidance and as well as support in facilitating the GIAN program submission and ensuring successful organizing of this event. And also I would like to thank our gratitude on the extended initiation of the GIAN initiation from the Ministry of Education and as well as the IIT Hyderabad nodal coordinators for providing us with this robust platform for necessary and resources to conducting these organization programs and enabling us to engage with cutting edge research in additive manufacturing and sustainable technologies and all. Finally, I would like to acknowledge the tireless effort given by this organizing committee and also including the head of the department, Professor Ravi Kumar, and registrars and as well as the deans and faculty members, administrative staffs and as well as the volunteers who work for this program and all. Your dedications and the meticulations, the planning have been pivotal to the smooth execution of this event. To all the participants for your presence and the enthusiasm are making us the program like this meaningful. We look forward to your assumed involvement in these sessions ahead, which is for the 5 days, and hope this program enriches your knowledge and the perspectives. Once again, I thank everyone making this inaugural program grand success. Let us embark this journey of learning the same zeal with the commitment. Thank you once again all. Thank you.
Thank you, sir, for the kind words and expressing gratitude on behalf of all of us. Let us conclude this session with the national anthem. I request you all to please rise.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you so much. Before we proceed for the high tea, I request all the dignitaries and faculty members and